So welcome everyone to this TFN lecture on changing Canadian icescapes. Let's begin by acknowledging the land and the people of the land. The Toronto field naturalists acknowledge this land through which we walk. For thousands of years, the land has been shared by the Wendat, the Haudenosaunee, and the Anishinaabe. Toronto is situated on the land within the Toronto Purchase known as Treaty 13. It's the traditional and treaty lands of the Mississaugas of the Credit First Nation. This territory is also part of the Dish with One Spoon Wampum, a covenant agreement between the Anishinaabe, Haudenosaunee, and Wendat peoples and allied nations to peacefully share the land and all its resources. Today, the land is home to peoples of numerous nations. We're all grateful to have the opportunity to continue to care for and share the beauty of this land. A warm welcome to everyone on our Zoom event this afternoon. We've shared this event on several social media channels aside from our TFN website. So do let us know in the chat how you heard about it, and we hope you'll come again. We also hope you'll join us as members of Toronto Field Naturalists. Thanks very much to the whole lecture team for organizing our lecture series this fall, including today's lecture on changing Canadian icescapes. TFN is entirely volunteer run, and we're always happy for new faces on our teams. I'll introduce our guest speaker, Dr. Lynn Moorman, shortly. First, a bit about today's theme. It is difficult to avoid ice in Canada. We have ice on our roads and in our hockey rinks. Canada is also home to an estimated 20,000 glaciers, and each winter, our Arctic sea ice grows to an extent that it becomes larger than the Canadian landmass. However, the response to glaciers and sea ice to increasingly warmer temperatures now threatens regional water supplies, local ecosystems, transportation, food security, and more. To focus public attention on those trends, 2025 has been designated by the United Nations as the International Year of Glaciers Preservation. TFN has done its part to help to make that information more available. We had a walk featuring glaciers back in February, and today we're delighted to have a guest speaker to help us grow public understanding of how Canadians depend on glaciers and sea ice. And so now I'm really delighted to introduce Dr. Lynn Moorman. And she is a professor in the Department of Earth and Environmental Sciences at Mount Royal University in Calgary, where she teaches spatial data science and physical geography. She explores Arctic regions as a researcher and guide with a focus on glaciers and glacial geomorphology. She also works with the Inuit in Canadian Arctic communities using near real-time satellite imagery to map sea ice conditions and keep community sea ice travel safe through the award-winning organization Smart Ice. Lynn is also a Canadian Geographic Travel Ambassador, a fellow and former governor of the Royal Canadian Geographical Society, and Canadian representative for the International Commission on Geographic Education. And so now, Dr. Moorman, the floor is yours. And I hope that you're able to set up your slides.
Thank you so much. I sure appreciate that introduction, and yeah, welcome to everybody. I know it's not the time of year when we're really welcoming ice, but it's coming, and let's focus on it today. It's a good chance to appreciate it. I'm just going to see, I believe I can share my slides here, my screen, and I am going to pop out of the slides at one point because it's interesting to use some different technologies other than kind of static slides to show some of what we're talking about today.
Okay, you're going to share screen?
Yeah, here we go.
Looking good.
Just need to, there we are.
Excellent.
Yeah, just you know, a little homage to the game last night. I'm sure you guys were up late. And I was as well. I think that's what we're all looking like this morning. It was a wonderful effort though. We were cheering even in Calgary and out west for you. So changing Canadian icescapes. When we first started talking about what this presentation would include, it was very much about glaciers, and I understand you you recently did a glacier walk, and I'd like to hear more about that. Perhaps it was about glacial landforms or how glaciers have sculpted the landscape, and of course, that's very much an issue across Canada. I'm just going to pop back here. I'm trying to get rid of my. I'm not sure if you can see it, but there we go. I had a little thing blocking my screen there. So yeah, ice has definitely affected all of Canada through multiple glaciations. Particularly, we see evidence of the most recent glaciation. We're dealing with changing glaciers here. We're dealing with what's happening with receding glaciers, with melting glaciers, the water issue. But I also really thought it was important to talk about sea ice as well. And that's because a lot of my work around climate change and ice involves people who are living on the ice. The ice is their road network. It's their home. I think we can actually relate to how people have to live on that. And with the changing conditions, how do they adapt? My bio introduced that I do spatial data science and physical geography. I think you'll see throughout how those things link up. It is very difficult now to study rapidly changing conditions, different kinds of processes, without using tools available to us, such as satellite imagery, drones, all kinds of geophysical tools, and being able to analyze and represent all of this data. So the technology piece is as important as the boots on the ground. I love doing both, which is great, but boy, the technology is changing every single day. Our learning about the icescapes are changing every day. So I will give you kind of an overview of what's happening in terms of our glaciers, in terms of sea ice, but there's so much more. So I have put my email address here, and you're certainly welcome to contact me. I've got some references I can provide if you're interested in a certain area, because this will scratch the surface, but I'm hoping it'll maybe have a few more aha moments for you, or thinking about the ice with a new perspective. So in Canada, oh, you might recognize this. This is around Niagara Falls. And we often deal with ice as a matter of inconvenience. When we're talking about sea ice, of course, I mentioned it's a lifeline. It's the transportation infrastructure. And with glaciers, glaciers really play a critical role in our climate. They reflect a lot of the sunlight, and so that energy that would normally be reflected if the glacier starts to melt and recede, of course, is absorbed by the earth. And this just sets up a positive feedback loop where we end up increasing the warming conditions. So that's a really important piece. I think when I'm teaching young people, they don't quite understand the importance. So we lose the glaciers. It has a very significant role for us. This is showing where we have glaciers. I'm going to start with glaciers. Of course, it is very important to note that 2025 is the UN International Year of Glaciers Preservation, and that is because we are recognizing the integral role of glaciers for climate, as I mentioned, but they're a data set as well. We'll take a look at that. They are our time capsule of climate information. Then we'll talk about sea ice, particularly, of course, in the Canadian Arctic. So we've got a little geographically dispersed areas to talk about today. These are where glaciers are actually located throughout the world. Of course, you can see more towards the polar regions, but where we have mountains, of course, and higher elevations, cooler temperatures. Now, are we losing glaciers around the world? Yes, absolutely. The glaciers across the world have lost 300 billion tons of ice every year between 2000 and 2023. One thing that the research has indicated is that the last decade, that retreat is much, much faster. We have a number of criteria in which we consider a glacier to be a glacier. It has to be formed on land, so that's where it's quite different than sea ice. It must be moving through gravity of its own weight. It must be composed of ice that's metamorphosed from snow, and it must be a certain size. So size does matter. So around the world, what we're finding is that there's countries that are losing the last of their ice. This is an example in Iceland, and you can imagine ice is very important to the identity of Iceland. This is Oakjökull, and jökull is the Icelandic word for glacier. The oak on the right-hand side is the current, it's the current view of the Oak Glacier. It does no longer retain glacial status because it is just too small. It's just a small ice patch now. This was the first glacier that we know of that actually had a funeral and an epitaph. And this was the letter to the future that was written by the Icelandic government. Oak is the first Icelandic glacier to lose its status as a glacier. In the next 200 years, all of our glaciers are expected to follow the same path. This monument is to acknowledge that we know what is happening and what needs to be done. Only you know if we did it. So August 2019, and there's the carbon dioxide parts per million. So this is coming to the forefront. So in Canada, are we concerned? Absolutely. But we're seeing in other countries, they're really, really acknowledging the loss of glacial ice. So here's where we find the glaciers in Canada currently. So of course, along the west coast, where we have the rugged mountains formed from the subduction of the Pacific plate and the North American plate. So we have that high relief area all along the west coast. And also the supply. Glaciers need an input of snow. So where you have very dry conditions, you won't tend to get that. So along the west coast, of course, there's this ample moisture. And of course, the winds are predominantly from the west. So that wind is just simply moved up those mountains. The moisture contained within will condense. You get a lot of precipitation. Of course, that's where our rainforests are as well. And you'll get a lot of snow. So that topographic and climatic intersection is really a haven for glaciers. Even there, we're seeing glaciers decline, even with the good supply of snow. Of course, where I'm located on that kind of confluence of the British Columbia and Alberta boundary, I'm going to see if I can use a little pointer here, maybe. That might help. Yeah, I've got a laser pointer. Can you see the laser pointer, Ellen?
Yes, we can. Yep,
Oh,
that's perfect. Yep, nice.
Okay. Yeah, so here we are. These are primarily the glaciers of the Rocky Mountains, and it's quite amazing. I'm about 100 kilometers from those mountains, and the precipitation difference is 20% in Calgary compared to what those mountains are receiving. So that's why we have glaciers in those mountains. We're still getting the effect of that western air system bringing the moisture from the Pacific across British Columbia, and that's sort of the last gas there. And those mountains take the rest of the moisture that feeds the glaciers, of course, and then everywhere east of there, we're in pretty dry prairies. Of course, we also have glaciers up in the Arctic, but you'll see not all of the Arctic. I've actually heard some references where they say all of the Arctic archipelago is covered with ice. Well, on the land, it's not. It's only where we see the Arctic Cordillera, and that is along the eastern coast of Baffin Island, Devon Island, and Ellesmere Island. So we still have some what we call ice caps and ice fields up in these high Arctic islands, and also quite a few glaciers around Baffin. These are really the remnants of the ice from the Laurentide ice sheet in the last glaciation. You'll also see just a little bit in Labrador in Torngat, so right in the northern tip of Labrador in Nunatsiavut. Now, throughout, I'll kind of intersperse, why glaciers are so important. And of course, for Canada, tourism is huge. I know in Alberta, Banff, Jasper Park, Yoho, absolutely. Glaciers are critical. People are coming to see them. They're stunning. Icefields Parkway has been named one of the world's most beautiful highways by National Geographic. Even in Newfoundland, icebergs are a huge tourist draw. And of course, those aren't icebergs coming from Canada, but they actually come from Greenland. And they take about 2 or 3 years. They're coming off the Greenland ice sheet. And it takes them 2 years because they first flow north and then turn around at Ellesmere Island and then follow the coast of Ellesmere Island, Baffin Island, Labrador, and then hopefully get to Newfoundland. They are really important. Of course, for Newfoundland tourism, you may have remembered a couple of years ago, yes, there was Dickieberg, and this iceberg ended up coming right into Conception Bay near Dildo, Newfoundland. And I think all of that whole combination of words could only happen in Canada. Of course, iceberg beer as well. So there is a lot of glacial influence and importance and identity. So I mentioned the Laurentide ice sheet. Also, I have the Cordilleran ice sheet in the west. And those were the two major ice sheets dominating Canada up to about 20,000 years ago. And then we had the Inuition up in the north as well. Calgary is really interesting. We're right on the intersection of that Cordilleran and the Laurentide ice sheet. And even though we have bedrock of sandstone, Paskapoo sandstone, when I go to the east and go 100 kilometers to Drumheller and I see big hoodoos forming, so big pillars of sediment in the Badlands, often there will be a nice cap of granite or granitic gneiss from the Canadian Shield that the Laurentide ice sheet has brought. Just to the west of Calgary, if I pick up a rock off the ground, it's not going to be sandstone. It's probably going to be limestone from the mountains. So in that case, the ice has brought those rocks, as it's eroded the mountains, brought them to us. So we have a lot of influence here from glaciers everywhere we look. That's probably why I'm interested in it. Calgary is also shaped by meltwater from the glaciers. So as the Cordilleran ice sheet started to retreat and provide a lot of melt, that Laurentide ice sheet was still in place and dammed the water that was coming from the melting Cordilleran ice sheet. So Calgary was home to Glacial Lake Calgary. So we build on Glacial Lake sediments. Some of our housing areas, suburban areas are built on Glacial Lake sediments. I don't think that's a good idea. It hasn't turned out that well. But it influences, the glaciers influence us everywhere. These spillways from the glacial meltwater form our main thoroughfares through the city as well. So a lot of impact. Now I mentioned ice sheet. That's a very specific type of continental ice body. So we've got the ice sheets in Canada. We also have ice caps, a little bit smaller. We have the Kluane ice cap. We have ice caps, as I mentioned, on Devon and Ellesmere Island as well. And we have ice fields, which again are a little smaller and elongated. And we have those just even in the Rockies. So the Columbia ice field is a key one for us here. And I wanted to mention these different types of glaciers, just for people who might not realize that they are different. They produce different landforms. The erosional and the depositional landforms they create are different. And when we talk about what the landscape looks like around Canada, particularly Western Canada, Northern Canada, this is what we're seeing, the sculpting of the glaciers. And I know you have some amazing formations as well, things like the drumlins around Peterborough. But here we are almost hit in the face with glacial landforms everywhere we look. So this is the cirque. The cirque is the cradles, and that was really important in terms of glaciation in the mountains, particularly north-facing slopes. That's where the snow would fall and not melt because it would be in shadow. So it would last persistently year to year to year. That's another condition of something being called a glacier. Now, as that snow stayed and then became glacial ice, it started actually eroding out the rock from behind it, making these bowl-shaped depressions. I think of them as cradles because it's really where the mountain glaciers, where they start, they grow, and then as they retreat, it's the last thing that's left. And the landscape in the front ranges of the Rockies, so Banff, Jasper Park, are absolutely dominated with these bowl shape depressions in the mountains. And of course, when you have one bowl against the other, that creates a very sharp ridge. And so you can see that in this image itself. This is Ptarmigan Cirque, really, really popular area for people in Western Canada. We also have, I will mention the valley glaciers, but the hanging glaciers, this is where we had smaller glaciers that were meeting the big valley trunk glaciers. And they didn't have to erode all the way down to that base of the big trunk glacier, only the top. So all of our waterfalls, these beautiful cliffs, were formed from tributary glaciers or smaller glaciers meeting the larger. And once the ice is left, we're left with these beautiful, beautiful cliffs. Here's our valley glaciers. This is what we see a lot of. These are either draining the ice fields or the ice caps, or they start in the cirques and then work their way down, just flowing like a river with tributaries as well. And I did want to mention tidewater in particular. This is the Walker Arm and Samford Fjord, Baffin Island, one of the most beautiful places to see glaciers. And these ones are actually going right to the water. So they're the ones producing icebergs. And I have to say, one thing I have noticed I've been working with glaciers for about 30 years, but in the last 10 years in particular, I've noticed so many glaciers retreating so fast they're becoming grounded. And what that means is they don't reach the sea anymore. So this is the coast of British Columbia, Alaska, Glacier Bay, especially, even in Greenland. When the glaciers don't meet the sea, they won't produce icebergs anymore. And I showed how important that was for Newfoundland, and people just love the idea of icebergs. It'd be quite sad to think of not too many icebergs remaining. I was mentioning about places losing their ice. The Alps have a 40% decline in glacier volume. They're trying to cover their glaciers with tarps. The Pyrenees, they just lost their last glacier. So the countries are losing them for sure. I just want to take this off. All right. So I mentioned glaciers are like a time capsule. They're basically like a sedimentary rock. One of the conditions of being a glacier, of course, is that you have a lot of snow that is deposited, it compresses, and eventually metamorphoses into ice, glacial ice. So much like a sedimentary rock. So we end up with these layers. And of course, you may have heard of ice cores. Last year, we were able to get a 1 million year old sample of ice, a continuous record of ice from Antarctica. And I'm just going to pop to this one here. What we actually see in those layers is evidence of things like volcanic ash. So here's the Eyjafjallajökull eruption in Iceland in 2010, and that stopped, I think it was 100,000 flights that were supposed to be going to Europe, it stopped air traffic for a very long time because the volcanic ash has little glass shards in it. You don't want that in your aircraft engines. But that record of that ash is contained beautifully within the ice. And we see that in Western Canada, Northern Canada as well. Of course, Antarctica and Greenland have very long records of ice. Right now, there is a very intense effort by scientists around the world, but particularly in Canada, to get these cores, get this climate record data before it's gone. We're actually losing the data if we lose the ice. One of the things we also look at in the core that's so important, like how we understand the climate, is we look at the air that's trapped, that still remains between the crystals. And although most of it is compressed right out of the system, there still is relic air. And we can actually take that air, and as long as we don't contaminate it with the current atmosphere, we can look at the air chemistry, we can look at the isotopes and understand, because they're a proxy for temperature, so we can understand if that particular time was warmer or colder. And so we can build that record. That's how we start learning about climate change. And when people say, oh, the climate 100,000 years ago was this, how do we know? It's these data sets that are rapidly disappearing. So glacial ice, really important that, I'm assuming, I think everybody is quite knowledgeable in this group, so I think you do understand a lot about glaciers. But I think it's important to realize like how that density changes, and it's a metamorphic process, right? It's pressure that's really compacting those snowflakes, so we really change the density. The timeline on the right-hand side, it depends on the climatic conditions, actually, of where the glacier is, how fast this process happens to where we get from snowflakes to what we call firn, or that corn snow, and then finally glacial ice. And that's just an example of those snowflakes, and then the firn crystals. So the snowflake arms, of course, wear off, and you get crystals that can be much more compact. That's where that air is expelled. That's why we see blue ice in glaciers if you get the front of it calving off. It's because instead of having that weathered surface where the wavelengths of light go in and then all reflect, so we see white. When you get that pure compressed ice, the light is going to go right in, and only the smallest wavelengths can come back out, and that's the blue. So this kind of scientific process of metamorphism really ends up having a beautiful effect. I think people are quite taken with that blue of the ice. This is just looking at some data about the local, again, the glaciers in the Rockies. The graph on the left is showing what's left of our glaciers here in terms of aspect. So aspect is the direction it's facing. And so, of course, those facing southeast, southwest, and west are going to be melting first. So if we're looking at which glaciers are going to be lasting the longest, it's the north-facing ones, and the ones in the east as well. The graph on the right is a discharge graph. Now, this work was done by Sean Marshall. He very intensely studied the Hague Glacier in the Canadian Rockies, and I can put you in touch with some of the work that he did. But one of the analyses he did was just looking at the discharge. So this is the Hague Glacier. This is about 100 kilometers from Calgary. And the discharge was the amount of water that was coming off of it. One of the absolutely critical roles of the glaciers here is to moderate the flow of water. So, and that's what we use for agriculture. We use it for drinking water. We use it for hydroelectricity. A lot of our water in June comes from melt. So snow melt. The glaciers can actually act as something that like provides a lag time. So what you're seeing is a big discharge there in August, and that's when we're not getting the rainfall. We're not getting the snow melt. The glaciers provide that meltwater and the water source that we need throughout the summer. So this is important for fish habitat as well. Alberta's quite famous for fishing. We're losing our native bull trout. They need at least they need water that's colder than 18 degrees. They need cold water, and they need water levels high enough. So the glacial water is really important for humans and the fish here as well. The glaciers here, we're looking at just British Columbia in the left and Alberta to the right, with the border in between. The glaciers are in blue, and those that are on the eastern side of the border, most of the glaciers are on the BC side, but those that are in Alberta feed our aquifers. So not just the streams, but that peachy colored area is one of our big aquifers that, of course, if you're living outside of the cities, you're going to be wanting to have well water access. And so that's a big concern, as well as we lose glaciers pretty quickly here, is what happens to recharge our aquifers. So not just streams. Here's Peyto Lake, one of those just absolutely classics. I'm pretty proud to have this in my backyard, I have to say. And the turquoise blue color is coming from the glacial flour. So that's a really fine material that's been ground up by the glacier as it's going over the rocks. And Lake Louise is famous for that, of course, Moraine Lake. So our tourism is strongly based on these beautiful lakes. One of the most important priorities for tourism in Alberta right now is trying to figure out, how do you sell this when the lakes don't have this color? Because as the glaciers retreat further, we don't get that silt coming into the lakes. So it's a concern for them as well. This is that same glacier. This is Peyto Glacier. And I wanted you just to be able to kind of see the lateral rates of retreat of this glacier. Some years, of course, are higher than others, and glaciers really do have a lag time. They're not like sea ice. Sea ice is responding really quickly. Like if it's a hot summer, we're not, or yeah, if it's warming, let's say a lot in the spring, we're going to lose sea ice really quickly. It's very responsive. Glaciers are not as responsive, so we're still seeing the effects from years past. We're not even seeing what's happening right now. And this is a big concern right now. The contributions to sea level rise as well are coming from these mountain and valley glaciers, more so than Antarctica and Greenland, because they're so much bigger, they're a little slower to react. And what we're seeing there is catastrophic, let me tell you, but we haven't even seen them really respond to some of our recent warming. So that's the same with the glaciers. But yeah, take a look at that retreat in 2020 and 2021, 195.7 meters. And that's just laterally. When we look vertically, some of these glaciers are losing 9 meters of elevation. And if you think about how big these are, that's a lot of ice that's lost. And so I think that's one of the big takeaways I really want people to have, is that it's not just the extent, it's the actual thickness as well. The Columbia ice field is really important to us. It is point, kind of a I don't know what to call it. It's a drainage divide, but 3 ways. So snow that is in and ice that is in the ice field in the Columbia ice field will go to the Arctic, will melt and go to the Arctic, will go to Hudson Bay, and will go to the Pacific. So it serves 3 different major watersheds. The Athabasca that you can see there, that is the one that is probably most familiar to people because you can go and walk on it. Now, back when I was young, and it's not 100 years ago, as a lot of my students might think, the ice was way over here. And I'm noticing the difference with the Athabasca every single year. Again, laterally, but the vertical difference is absolutely shocking. So this is a valley glacier, and you can see how it's draining the Columbia icefield. Same with the Saskatchewan here too. So that's how those glaciers kind of work together. So the Athabasca Glacier is where there's a visitor center. Brewster has a snow coach that can go up onto the glacier. And back in I think it was 2020, or 2021, there was an accident where it actually rolled off the slope. And that's because that vertical depletion of the ice is meaning that they have to get those big snow coaches down some pretty steep slopes to try and get down to the ice now. And that business is really not feasible any longer. So one of the keys that we're, I think, also kind of seeing and trying to get across, this is not in Canada, but it's so close. This is the Mendenhall Glacier in Juneau, Alaska. And it's Juneau's capital of Alaska. It's got a glacier right beside it. So I think in terms of living with glaciers, they know this very well. There's been 3 major floods in the last 3 years because as glaciers start to melt back, there's more meltwater, but also sometimes that water is stored under the glacier and it can come out as a massive flood. Or in this case, this glacier is actually holding back meltwater from another glacier. And there's so much melt coming off of that it can actually either lift the ice or start going over top and then carve a channel through. And that's what's been happening in Juneau. Houses have been washed away, houses have been flooded. This year they put up some barricades. They kind of got the idea this was going to be an annual event. But this is the Mendenhall Glacier. It's a nice time lapse. There's 3 things I want you to see. How the glacier is retreating back up the valley, the vertical loss as well, like how that's changing, and the idea that the ice is just a conveyor belt. It never goes in reverse. The ice is always moving forward. So even when you see it retreating, it's just like the conveyor belt getting shorter. The ice is never turning, all of a sudden going backwards and pulling back. It's always, always moving forward. So let's just take a look at this. Quite something. One way that we can actually measure the glaciers moving is through, as I mentioned, satellites. So this is an interferogram. It's when we take 2 radar satellites in space and we can measure the actual surface of the ice, and then we have a second measurement, either from a satellite following behind or do another repeat another time, and we can actually measure how fast the ice is moving. So this is really important so that we get a sense of how the glacier itself is changing, and then if there are any issues, like I mentioned, with the flooding. This is on the Athabasca, and I should say the Athabasca has lost half of its volume since 1900, and a lot of that has been recent, of course. This is NASA. Why is NASA here? Well, the Athabasca provides an amazing test bed for other planets, other moons. So in this case, they're testing robots that will be taking samples, looking for different extremophiles, different forms of life on moons of other planets where the surface might be ice covered, but there's likely water underneath. So we're testing the robots. The one on the left is the eel. It actually moves by itself. It goes down into the crevasses or the cracks or the moulins where the waterfalls are in the ice and goes down and samples. I think the other one right there, it actually lowers itself through the crevasse. So NASA's been testing these types of robots and instruments out. So again, glaciers are absolutely really, really critical for research about our own planet and of course about other places as well. I did want to mention when I showed you those the retreat rates of Peyto Glacier, and 2020 was quite substantial. So even though we do see, it's a lag time that we get from glaciers, 2020 was an interesting year. We had such bad wildfires here in 2020, oh, in 2021 that I think you can see this here a little bit. You can kind of see on the ice, it's not clean ice. It actually gets quite dirty. So there's a, a almost a dirt or dark film on the ice called cryoconite, cryo being ice. And conite is it's where the algae are actually colonizing, the soot, the ash, just the dust, anything that's falling onto the glacier surface. And of course, it becomes quite dark, which then furthers the melting of the ice. So a lot of the ice that we're seeing now is really, really what we call dirty, but it's this cryoconite on it, making a very, very dark surface and just accelerating the melting. So maybe, Ellen, did you want to take just a quick break and see if there's some questions about glaciers before I just talk about sea ice?
I bet you there will be questions. Why don't we, I mean, there's so many things that you've mentioned that I think are fascinating, and so much of what's going on in my mind has to do with public awareness and the extent of public awareness. That video that you showed of Mendenhall Glacier, for example, is the kind of thing that really should be shown like it should be viral. Perhaps it has gone viral here and there on social media. But I think what often is certainly the wildfires of the last few years have taken a lot of media attention, and deservedly so. It's just the question of why, as a country that has so much in the way of glaciers, do we talk so little about it? It's a bit of a mystery. Someone here
Yeah.
is saying there's a documentary film, Chasing Ice, about
Yes,
time lapse videos of many glaciers worldwide.
that is worth seeing. That will change your perspective. Yeah,
Yeah.
absolutely. Chasing Ice is a phenomenal video to watch. It depicts or it shows one of the glaciers, the valley glaciers in Greenland, losing more than the size of Manhattan in terms of ice and the volume and the extent. And it takes about an hour for all of this ice to just break off, and it just goes on and on. And it was a remarkable capture, but the story was all about this fellow wanting to share what's happening with glaciers and setting up the equipment to document such things. So that would be well worth anybody's time to watch.
Yeah. I'm also thinking of I think it's the reporter Elizabeth Colbert in the New Yorker, writes for the New Yorker, and she's written a number of books, and she's also featured Greenland studies. Yeah. Same sort of thing. Yeah. Why don't we move on to this
Yeah,
ice?
sure.
Yeah.
Yeah. And I just wanted to show you this as well. This is just the free Google Earth. I often use Google Earth Pro, but this is the free Google Earth. This is showing, this is the Head Glacier that I talked about. And I want to show you something I discovered when I was looking here yesterday. And the reason I was looking on this was because you can actually do a time lapse on here to show. Let's see if I can make it go. Might be a little slow, but it'll show you know, kind of imagery over time. Let's see, oh, it's not. I think it wants more bandwidth than I've got right now. Oh. But that's a great tool for people to take a look as well. You can see, you can get the idea of it here. And so you can actually see, you can literally see the glaciers in the Rocky Mountains just disappearing. We expect them to be gone by this next generation, like my kids' generation by the time they've got grandkids. So one full generation. One thing I wanted to show you though, I discovered this. Look at these tracks. So this is very interesting. This is the Canadian Olympic Development Agency went up and created their cross-country ski training camp up on the Hague Glacier. And at the time, this is about 1990, there was quite a bit of outrage because it was not done with any protocols, any kind of advising on the environmental side at all. And the reporters who went up to go do the story, the environmental minister said, I can't give you permission to take helicopters. It's too environmentally sensitive. So that the reporters hiked in, and then they watched 9 helicopter flights bring skiers in and out to the glacier. I think there's things like this happening around, but this was just one interesting story that I just came upon while I was looking at imagery this weekend. So, okay, and I'm just going to pop into our sea ice here. Oh, can you can't see that, I don't think. Let me make sure I'm sharing.
Yeah, we're not sharing.
Yeah, I've got it now. I got it. Yeah. There we go.
Looks good.
Yeah, great. There we go. So again, sea ice, now we're looking in the Arctic. And the sea ice is just absolutely critically important. I mentioned it was it's the infrastructure, it's the transportation infrastructure. It is a grocery store. So Inuit survive on country food. It's seals on the right, they're waiting at a seal hole. Arctic char, there's all kinds of fish. They also will hunt mammals. The ice flows. This is right at the edge of the sea ice with the ocean. That's where a lot of mammals will be. And when Inuit are eating their traditional foods, they get all the vitamins they need. Fruits and vegetables aren't part of that diet. They don't need them. It's all provided by a traditional diet. So, but you need sea ice to access that diet, of course. So ice is completely part of the culture. This is my friend Andrew taking his little boy out, teaching him about the ice terminology. So what you're looking at is the sea ice. It's probably about 3 feet, 4 feet thick, and about a kilometer of ocean water underneath that. And then you see the land in the distance there. So there's terminology in every single community that might be a little bit different than other communities because the ice has different character, it has different seasonality. So there is the ice is part of the language, and it's been orally passed on. Of course, there was a huge disruption when many Inuit were taken to residential schools. So I still see people in the community struggle with the young kids only speaking English, the elders only speaking Inuktitut, and people in between just really, really trying to pass on information. So if we look at where that Arctic ice is distributed politically, Inuvialuit over in the west, and then Nunavut, Nunavik in northern Quebec, and Nunatsiavut in Labrador. And yeah, there are people spread out everywhere there. Of course, we don't mention the density in terms of people per square kilometer. It's actually 50 square kilometers per person up there. So the communities are quite isolated, but there is so many ties between communities. There's volleyball games, there's hockey tournaments. One town will travel 100 kilometers over the ice to get to the other town for these. And these are many of the traditional trails that you're seeing. So anything that's over the ocean there is, on ice. You can see why the ice provides a much better transportation network than the land. This is in the Eastern Arctic. So of course, you want to travel on the smoothest way possible. This is just to show you what that surface is like. We were there in April. This is about -30. I'm trying to fly a drone bare hands, but just gives you a sense. It's not totally smooth either. This is fairly smooth, but you can see how rough it could be. So that's one of the things that we're kind of interested in the sea ice is like, how rough is it? And people will traditionally, they'll use snowmobiles, but also dog teams as well. So one of the big concerns there is, as I mentioned, the ice is changing. It's changing in extent, it's changing in thickness, and it's changing in terms of its seasonality and when it starts to break up and where cracks are forming. So if you're on your skidoo and you can't find a way to get across a crack, you're wasting a lot of gas and you might get stuck out there. One of the big problems, of course, is that when you're up north, this isn't even in at the winter solstice, this is in November. That's the Arctic Circle in orange. And just going through some days pretty quickly to see the daylight, they don't have daylight for a lot of the time that the ice is in place. And so they're really running with their traditional knowledge about the ice, where to go, where is it safe, where is it not safe. The issue is the conditions are changing so fast that that traditional knowledge isn't necessarily kind of keeping up with modern conditions. And so there's actually a request by Inuit for technology support. Like how else can we view the ice in order to keep us safe? Slush is another big issue. This is my friend who was out. He was trying to get to a hunt location, and that's how he earns his money and how he gets his food. And he should have been traveling on just nice, clear ice. This was in March, and in the past he would be able to go out almost till June on the ice. And so this is massive wet slush on top of the sea ice, and then of course ocean underneath that. He's actually fallen through the ice. Many people have. That is how we lose people. And he mentioned just going down and just seeing that hole where he fell, and that hole above him getting smaller and smaller. And his gun strap had him caught on the skidoo. And yeah, he made it back, and a lot of people don't. So this is a big concern. And getting stuck in slush, where especially if you're in the darkness, dark conditions, and you run out of gas and you've been out for a few days. I mean, they go out for quite a long time sometimes. If you can't communicate with people back home, how do they know where to find you? So search and rescue is a pretty important part of every community. This will show you, and you've probably seen things like this. This is the sea ice extent changing over a couple decades. But what I want you to really look at is the color, the tone difference. The white ice is the thick, old ice. That's the ice that you want to have. The dark gray ice is first year ice. It's just single year ice. It'll come and go. But that ice that remains year after year is that white ice. That's the important thing that we're losing. So again, it's not just about the extent, it's that that thickness as well. So yeah, and by 2018, we don't have much of the old ice left at all. One of the things when we travel through the Arctic in the summer on ships, sometimes we come across a lot of ice, and in areas where we kind of don't really expect it, and people go, oh, so that means that global warming isn't as bad. So I'm thinking particularly in here, this is also where Franklin got stuck when he went on his quest for the Northwest Passage. And the reason we're seeing that now is because in the past, these islands up here, and especially in the Narrows Strait, up in Greenland and Ellesmere Island, had like a bottleneck of ice. They had thick ice that blocked any of that old ice from draining out. Those are pretty much gone now, or they're disappearing, and they allow those open areas now allow ice to drain out. So we do see now sometimes in the summer we'll get these big bunches of ice, and it doesn't mean that things are better. No, it just means that we've lost these controls on keeping the old ice and the sea ice up in the Arctic. Oops. Oh. There. So lots of headlines of that over the years. How do you avoid falling through the ice? Gonna make this a little smaller. Thank you. There. Yeah, the ice is thinning. So it's not just a physical concern. It's like, remember in COVID when we couldn't go places? That's how Inuit feel as well. When they can't get out on the ice, they're very isolated. They can't see their friends. They can't go see their family in other places. It's much like COVID. And there is a very important mental piece to what's happening with the sea ice disappearing. I do want to tell you about just some of the adaptations so that it's not all not doom and gloom, but here's what people are doing. Here's what we're trying to do to help people live with this. Again, this is with the organization Smart Ice, which is a social enterprise. These are ice buoys. So they go into the ice. They're like thermometers. They measure the air temperature, the snow temperature, the ice temperature, and then the water temperature underneath. And through telemetry are constantly letting people know what the ice thickness is at that particular point. There's an app that Arctic communities Inuit have that allows them to access that data at any time and also share other information about the ice. So that's one particular thing. This is another. Here's the snowmobile with the Comatic behind it. We call it a smart Comatic or sled because it's got an EM31 instrument on the back, and that acts like ground penetrating radar. So the energy will actually go through the snow and the ice and get to that ice water interface and bounce back and let us know how thick the ice is in real time. On the front of that snowmobile is like a touchpad with the information coming. So it's what you end up with is a map, just like a road map for us on the left where we see traffic. On the right-hand side is our roadmap of ice conditions, where it is going to be too thin to travel. And again, that is available on the app that people have. We can do a bigger scale of that so that communities can see what the ice is like in their hunting areas or where they might want to go. This is what the government provides. Here's my friend in Tloyak where the yellow star is, and all you get from the Ice Center is, oh, the chart's not available. That's because the Ice Center traditionally has been really focused on shipping in the north and looking for weaker ice, like where can you go where it's better to move a ship through ice. And of course, the communities are the exact opposite. They're looking at still large areas, but not as large as what the Ice Center wants to look at. They're looking at thick ice. They want to know the character of the ice. Is it really rough? Are there pressure ridges that they might accidentally hit as they're going through on a snowmobile? Are there cracks in the ice? So the Ice Center is working on initiatives now to try and help address this, but Smart Ice has really been the leader in addressing community concerns all across the Canadian Arctic. So the solution is what we call IQ. It's Inuit Kauyimiyatuhanik. It means the knowledge and values about the ice. Remember I said ice is part of the culture. And so we need to kind of take that knowledge that's been passed down through oral traditions and put it in something that can be shared amongst the communities and especially those that aren't speaking Inuktitut. And so that is a whole program of participatory mapping, where we're actually getting elders and hunters to map out their knowledge. And then we go back to satellites, looking at optical, which we need the sunlight for, or radar, which we don't, to try and help map out the conditions, and then put all of that knowledge together in a weekly map in the community. And this is not done in the South. This is done in the communities by the community members. So there's a lot of training that happenings and a lot of like knowledge skill development. That's fantastic, actually. These are some of the knowledge coordinators. You can see all the terms in the back here. This is trying to just collect what are the ice terms used in this one community. There are books made with illustrations, and it's done in Inuktitut and English, describing all of these different conditions so people know. I don't think I shared the voice here, but Sandra's going to try and pronounce this. It's like Idioktuk. And this is broken ice, pushed ashore, stays still melted. So just a few examples. The communities that we've done this work with, the books are given to every household of the community. And a natural ice bridge between the cracks. So you want this mapped out so that you know how to move through the cracks. So here's the participatory mapping that's happening with elders and hunters. That information is put into paper maps, and then some of the youth in the community are trained in digital mapping, geographic information systems, to actually make these into paper maps, or sorry, digital maps that then we can print out for the community, but we have all this data in digital form as well. This is one for Pond Inlet. So we can look at optical imagery through satellite, much like you'd see with your eyes, and you can see the cracks. You can see where and this is probably, I would say, at least 50 kilometers across here. This area here is like just rotten ice. You wouldn't want to be on that. And here's the ocean here. So that's very helpful, just getting that bird's eye view of what the ice conditions are. So when we do have sun, we can actually use the satellites to capture the reflectance of the ice and understand what's happening there, like the image you just saw. But in those dark conditions, or when there's a lot of clouds, we need radar, and radar will actually send out its own energy pulse and measure the return. And of course, Canada's a leader in radar satellite remote sensing. And the Space Agency is planning yet another new system. So just on the left, you can actually see that radar. It's changing a bit with the ice conditions. Yeah, so in terms of some of these programs and training people, we do a lot of collaborative interpretation, trying to see, this is in Nain and Labrador. There's a lot of open water that stays open all year long. So we're trying to map those out, actually getting on the ice to interpret radar data, and using a lot of community and culturally specific iconography. It's like symbols, words, of course. If you take a look at the symbol right here, it might not be intuitive to us, but for people living in this area, it's exactly what this is. An iceberg that's in the sea ice, and it anchors the sea ice, so it's safe around it. It also provides fresh water. So this is not something we can do in the South. This has to be done by people in the Arctic for people in the Arctic. So a lot of mutual learning happening in this program. I'm just going to show you a few of these maps that are made in different communities. They look different because each community wants something a little bit different, and there's different cartographers, of course. So definitely, while this doesn't change anything around climate change and sea ice, It is a tool to help adapt to living in such rapidly changing conditions. The harpoon is a symbol. That's because when you go out in the ice, even with these maps and with your knowledge, you still want to use a harpoon. So 3 taps of your harpoon without going through means you can safely go across on a snowmobile. So there's no crystal ball, but certainly there's a lot of interest in trying to take these technologies, integrate technologies with the traditional knowledge of Inuit about the sea ice. Technologies, of course, are playing a huge role with the glaciers as well. We are always trying to get students interested in, learning about these fields. And this is in geography. So this is kind of funny because a lot of people, and I've talked to people in Toronto even, who say, my kids are interested in geography, but I don't know what kind of jobs they could get. And I have to say the opportunities are pretty endless because we've only looked at climate and in terms of ice here. And I think you've been able to see where some of that technology plays a role. So there will be, as things progress, we want to learn more, we want to understand more, we want to help people adapt. And so that involves that boots on the ground research, but the technology side as well. So a little glimpse into what's happening in sea ice and glaciers in Canada. I've put the Smart Ice URL there as well, just in case anyone wants to take a look at that organization. They're doing a lot of amazing work. And they've been recognized around the world for that work too.
That is wonderful. Thank you so much. It's really been illuminating, and I don't really know where to begin. I mean, people, inevitably people take it back to their own personal experience, and
So
I was.
there's, sorry.
Go ahead, Pete. Yeah.
There's one question. What was the time frame of the time-lapse video of the glacier retreat? Guessing that's the one around Juneau.
I think that was, if I remember, I think it was like 2 winters, so maybe like 1.5 years. 2 years, maybe a little more. I'll find out and give you the full answer to that. It's not long though. It's not long.
I have a question. So there's a lot of there's basically like little ecosystems underneath the Antarctic icebergs. Is a similar thing happen in the ones from Greenland or Canada? The ones that are like going out and down?
Oh yes. Yeah, I'm just gonna see if I have a little picture of some such things. I just, I'm not sure if I do. There are, we have a lot. We have ice worms. I mentioned the algae and the cryoconite as well. And we have something else that is, what are they called? The springtails. So little glacial fleas as well. So there are things that are actually living, like this is in the glaciers. So in the glaciers, when we don't tend to think of things living in the glaciers, with the sea ice, we see quite a lot of life as well. I mean, I've seen even like jellies go by and yeah, jellyfish and things like that. So there's a lot of life that we're just learning about.
Yeah.
I'm just gonna grab
Cool.
see if I can grab a photo of those.
There is also in the deep history of planet Earth, there are those 2 periods of time, or 1 or 2 periods of time, when we had ice ball Earth, and that was initially a theory, and I think it's become more and more and more corroborated. And so there is this the evidence is gathering that a lot of our basic life forms were forced to adapt very quickly to those periods when the ice covered the earth. And so even things like the very earliest algae, the very earliest fungi were were freshwater aquatic forms that lived in these ice pools on the top of ice. And so in a way, you know, you could say all our ancestors came from ice, which is mind-blowing in itself, right?
Well, and you can see why NASA is interested in spending, investing in creating these robots to collect data.
Yeah.
I'm just so you can imagine what this looks like. I'll just pop into this really fast so you can see it.
Oh, cool.
So that's a cryoconite. So that's algae that's colonizing the soot and the dust and everything in there. There's some of the algae. And so sometimes we see on the ice, we get this pink ice, and that's algae on there. Here's the ice worms. This is actually from Mount Rainier. A bunch of them came out last year. So it was quite fascinating. They like to live right at about 0 degrees, and they'll kind of move up and down in the ice.
And they are a form of worm, or are they a larval insect, or
They are a worm.
they are a worm? Wow. Yeah.
The little fleas, so that's the
tardigrade
tail on the right side.
Yeah.
Yeah.
Cool.
Oh, we also have viruses and bacteria, of course, in
Yeah.
the ice and in snow patches. That's a whole other that's a whole other conversation, isn't it?
Yeah.
I'm going to combine, Michelle and I have very similar questions. So I think it's called the Buried Valley Aquifer, which is the one under Calgary and Red Deer. I think that's what it's called. Is that declining, or is it, I'm assuming it's declining, and how quickly is it declining? And Michelle was specifically asking about, like, in 5 to 10 years, what's the status of that?
I don't know. I don't research that end of it at all. I think like where the work has been going is just trying to figure out what's recharging that aquifer. And so the last paper on that, there was, I think it came out like 2 years ago, saying, yeah, we know that the glacial meltwater is actually recharging some of that and is pretty important. So I don't know if it's declining now. But certainly if we lose our glaciers, we know we do know that will be declining. So
And what is your sense of, you know, the interest level in Calgary and surrounding areas in that theme? I mean, on, you know, on a scale of 1 to 10, or compared to other environmental challenges, is it sort of a maybe, you know, don't bother me with that, or how, you know, how, what's the level of interest that you
like with the glaciers specifically,
beg your pardon?
but with glaciers.
Yeah, well, with glaciers, but also with this connection with the, you know, the water supply. I mean, the Bow River and aquifers, and is there a sense that, well, technology will find some other way, or to resolve those challenges, or?
Yeah, I would say there are some environmentally aware groups such as yours who would be aware and like know and be curious as to what's happening. For a large part, there is not an awareness at all, I would say. And then I think for some that are, it'd be like, well, humans solve the problem, so we'll solve this one as well. And what I find with my students at university is that when I get them to map glacial retreat, I just did a thing last week where we talked about, what do you know about glaciers? And they went, we know nothing. We know nothing. We live right beside them. I can do a day field trip onto the Athabasca Glacier, and the students I take up there have never seen a glacier unless they're in recreation where they're doing backcountry skiing. But then they're not as much they're looking at it from that lens and not so much that environmental and connected lens. So I would say it's not high on the radar. Media is starting to do a little bit more with that, but
Mhm,
Yeah.
mhm.
They love to pump their water and get some more oil out. It's like they're going to become the real have-not province. No water.
Mm, yeah. Well, I mean, I guess for several people here on this afternoon, there's this. Our minds are going towards growing public awareness, or trying to understand what it is that would that would have leverage. I mean, if you go back to previous decades, I think there was quite a surprise to learn that the charismatic megafauna like polar bears were in trouble, and that there's sort of been a numbing about that. Well, it's a sort of thing that happens. um, do you know there? Tell us something else.
Yeah,
And
no, I will. Like, I actually this weekend, and during this week at the Banff Mountain Festival, there are 2 days dedicated to glaciers, and kind of combined with wildfires as well. But glaciers, and it's the artists. The artists are the ones right now who are doing just remarkable communication around glaciers and conservation. And so it's them, and it's as I mentioned, there's a real push in the scientists to be getting cores and getting the data before it's gone. And so the media will cover that, but I see in the artists, and I'm trying to get out to Banff. I've got another conference going on, but I'm going to try and get out there just to hear and see what some of the initiatives are with the artists. There's a Swiss scientist here as well for that, and we're both doing a panel on, I think, Thursday, and he's talking about how they've been using visualization, so like 360 and photospheres, and doing displays in public that help the Swiss population understand what's happening with their glaciers, because it's really bad there. And of course, I think more of the population is more directly connected to glaciers. And I think that's a hard thing here, is everyone, even in Calgary, I think they're just so distant, and they're not connected to them.
yeah, yeah. Well, and I know, I mean, from what I understand, that the glaciers in the Alps and Switzerland, this sort of the idea of protecting key areas by tarps or key sites, they're also anxious not to suggest to anybody that that's a solution. That at most, we're talking here about a hectare or something like that, or an acre or so that can be protected.
Yeah.
So they don't want to look foolish and give people entirely wrong ideas. You mentioned that former glacier in Iceland that has, there's the plaque, and it's deemed dead. There's also a film that I saw, a documentary, and it must have been put out in the for this international year, sort of spoken or narrated from the point of view of that glacier. And it might be a little bit hokey, but it provides that personal perspective, this idea of history and sorrow, and bigger perspective.
Yeah, I might have seen that. It might have been a different one, but there was actually like tombstones for all the different glaciers that had passed.
Mm-hmm.
And yeah, it's quite something when you realize that there's
Yeah.
places that have had them, and they're gone now.
Well, I really, really appreciate the work we all do, the work that you do and your colleagues in understanding the basics and the dynamics and the rapid change, and this being able to translate that information to make it available and an adaptive tool for the communities. This is so powerful, and I think that, I guess, is provides a sense of hope, and realizing that we all need to think more in terms of adapting as well as dealing with the root causes. So thank you so much for your time, and the fact that you're going to offer your email, and you're open to further questions. That is really terrific. Michelle has asked about the Smart Ice funding and whether it's secure.
Yeah, it's not. I mean, it's secure for a few years, and it's always part of the effort is to make sure, because everyone doing all this mapping work, all the Inuit in the communities, that's their job. They're hired. The smart buoys, those ice buoys, they're created by youth in Nunatsiavut, and there's a new production center in Arviat that's just happening. So these youth are it's a whole mentoring program. It's their job. They learn all of the physics and the electronics, and build these devices, because it doesn't make sense for them to be built down south and shipped north. So yeah, there's always people are always on the lookout for where are we getting funding for the different parts of the programs too.
Yeah, that local empowerment, and the capacity for them to, to do things for themselves. Yeah. So all power to you and your colleagues, and I thank everybody for having been here this afternoon, and we'll see you again. So do talk about this with your friends and family. Absolutely. Okay, thanks so much.
Thank you. Bye.
Thanks, everybody.
Bye.